Hi guys, welcome to the next part of DC machines. Okay, in the last class we have been seeing some basic questions from the fundamental of DC machines. In our today class also we are going to do the same thing. Let us slowly increase the core weightage. So now let us take the next question. Just follow the rule always while learning any lectures. Not only while learning the lectures. If you want to increase the interest in something, you must we create some enthusiasm. It's not உடனே வந்து உங்களுக்கு ஈஸியாக எந்த விஷயமும் வந்துடாது. While learning any concept you must keep some interest into that is very important, right? So always keep smile in your face while learning any concept, and pause the video for each and every 20 minutes. Close your eyes, recollect all the new concepts that you are learning from this since this last 20 minutes. Okay, let us start the first question. So here the first question is, consider the following part of DC machine: yoke, armature core, brushes, pole core. Now the question is, which of the above parts are subjected to iron loss? Can you please tell me the answer for this question? Which of the above parts are subjected to iron loss? You know, iron loss means it is the combination of hysteresis plus eddy current loss. Now, which are all the above parts are subjected to iron loss? Drop your answer. Take your time. That's not a big deal, but don't take too much of time, right? Just you can tell me the answer simply in a simple way. Okay. So let me tell you, generally we will have this iron loss in which where we have magnetic material, non-magnetic material. Sorry. So generally, if you consider in non-magnetic material, if you take, they are talking about iron loss, right? If you take non-magnetic material, you cannot observe. Sorry, I think I released some wrong words. Let me tell you. Generally, non-magnetic material, we cannot observe these losses, right? What type of losses? This eddy current losses plus hysteresis losses. Combinedly, it is called iron loss. It should not occur in case of non-magnetic material. So you can observe the losses only where you have the magnetic material. Only where we have magnetic material, that we know. Now they had given four options, like they are talking about yoke. Yes, this is construction, right? And they are also talking about armature core. And another one is they are also talking about brushes, and another one is pole core. Out of these four, which one is subjected to iron loss majorly? Sir, we know in our DC machine, just you might have observed this structure here. What type of structure it is? Just observe here. Armature is always placed in the rotor side. If you observe the structure carefully, you might know this thing. See, armature, this is armature winding. The rotating part is there, no? This is armature winding. Armature is placed on the rotor, whereas field coil is placed on the stator. So always this armature winding is majorly subjected to iron loss and that is iron loss means okay, iron loss and copper loss, right? Anyway, they're talking about only iron loss. I'm also sticking myself to iron loss. Iron loss means you can observe the hysteresis losses plus eddy current loss majorly from the part of armature core winding. Whereas this yoke part and this pole core, if you take in yoke, we are not passing any field coils and we are not adjusting excitation values. Even in pole core also, pole core will simply uniformly distribute the flux. That's all. That is the one and only work. And we are not adjusting the value of flux density from pole to pole in order to observe this kind of what I can say stresses and eddy current losses. So since the field excitation is constant from the stator side, So there will be no form of variable field excitation. So there will be no chances for getting hysteresis and eddy current losses from yoke and pole core. Then what about brushes? Brushes, we can say it's a non-magnetic material. We all know. So brushes are made up of non-magnetic material. In the sense, in non-magnetic material, you will never observe the properties of this. That is, you will never observe hysteresis and eddy current losses. Then what is the correct answer? The one and only answer is armature winding. So the correct answer for this question is option B. Sure. Take the next question. What they told. The armature of a DC machine is laminated. Okay, the armature of a DC machine is laminated. Why we are laminating the armature of a DC machine? Just now we have been observed the armature is the person in which we are observing hysteresis losses and eddy current losses. Simply we can say iron loss. Of course, copper losses also you can observe from the armature winding, but copper losses will also be observed from many other places. So I'm only talking about iron loss. Anyway, what they are talking, why we are laminating armature? If I will laminate the armature, what will happen? What is the benefit of laminating the armature winding? That is the next question. I had given the answer for this question already. You can simply say. So actually what will happen is, if we always lamination means it is subjected to eddy current losses. Even you might have read these things in transformer also. You do remember these things. Eddy current losses always. Whenever you are laminating the core, automatically eddy current losses will be reduced. Even in transformer also we did the same thing. So with the help of lamination we can reduce the eddy current. So what is the correct answer? Option B is the correct answer. Okay. Take the next one. What are all the slat wedges in a DC machine of made of? DC மிஷின்ல ஸ்லாட் வெஜஸ் வந்து எதுல வந்து மேட் பண்ணிருப்பாங்க அப்படிங்கறதா கொஸ்டின். Right? Anybody know the answer for this question? They are given four options: mild steel, fiber, cast iron, silicon steel. What is the correct answer? Actually, where we are using this, as we know, we are always trying to maintain the air gap between the stator and the rotor as minimum. We have to maintain minimum air gap, then only the reluctance will be minimum, such that flux can be uniformly distributed throughout the field. And if you provide slat wedges, the beauty of this slat wedges is it will helping us to maintain, or it will reduce the air gap. It will reduce the air gap. If air gap will reduce, it means air gap will become minimum, reluctance will become minimum, flux can be uniformly transmitted easily from stator to rotor or rotor to stator. So that is the advantage of using these slat wedges, and we are manufacturing it with the help of silicon steel. That's all. So what is the correct answer? Option B is the correct answer. Fine. Next, in a DC machine, for the same number of slats and the same current, see they are talking about same number of slats, okay, same current in the armature conductor, which one of the following will induce the higher EMF? Induced EMF வந்து எதுல வந்து அதிகமா இருக்கும்? That is the question. Which type of winding? Whether it is lap winding or wave winding, compensating winding, pole winding. In which area we can observe maximum number of, that is maximum amount of voltage? That is the next question. You can apply your common sense to figure out the answer for this question. You don't need to expect the answer from my end. You can just try, and then I will give the answer for this question. Okay. Actually, anyway, you guys might know the answer. First of all, we can neglect this common setting winding and pole winding. Our only focus should be on lap and wave winding. So let us discriminate them. Let's see. Actually, we have two type of winding, right? One is lap winding, and another one is wave winding. What is the major difference here? The major difference, lap winding in the sense, immediately the things that will be coming to in our mind is number of parallel path in lap winding will be equal to number of poles. When you go for wave winding, number of parallel path is fixed, it is 2. So now the conclusion is, sir, அப்ப இந்த மாதிரி designing வரும்போது, when the number of parallel path is equal to number of poles, in that case, we cannot give assurity whether the voltage is more or not. But what I can say is, let us take for an example, we are taking a 4-pole machine. Then what will happen? Number of parallel paths will become 4. Yes. So in lap winding, always the number of parallel path will be decided by the number of poles. So if poles will become 8, then this parallel path also will become 8. So what is the conclusion, sir? The conclusion is, let us take, I'm having 400 turns. Okay, I'm having 400 turns. coil turns, 400 coil turns. Let us take what will happen is, in case of wave winding, these 400 turns will be broken into 2 off. Because here we have only 2 parallel paths. So this 400 turn will be broken into 2 off. 200 turns in the first line, 200 turns in the second line. Such that suppose per turn, one turn is generating 1 voltage, then I can say this total 200 turns will going to generate only 200 voltage. We are having 200 turns, and since these 200 turns and these 200 turns are connected in parallel condition, voltage will be remain same. If 200 voltage will be induced in this coil, same 200 voltage will be induced, such that in this terminal, if you observe the voltage, net voltage will become only 200, it is fixed. But if you go along with the lap winding, that is not the case. In lap winding, let us take 4-pole. If you take 4-pole, then parallel path also will become 4. Then what will happen? This 400 turns will be broken into 4 off. If you divide it by 4 off, then what will happen? Each and every parallel path will carry only 100 turns. It means if one turn is generating 1 voltage, 100 turn will generate only 100 voltage. Since all are connected in parallel path, so if one line is generating 100 voltage, then the total line will generate only 100 voltage only. Why? Because in parallel circuit, the induced voltage will be remain same. So that is the problem here. Now you might think, sir, நீங்க 4 pole எடுத்துட்டீங்க, suppose இப்போ 2 poles எடுத்தா என்ன சார் ஆகும்? Yes, that case is possible. Suppose DC machineல 2 poles இருந்தது அப்படின்னா, we can go with this. But I hope you all have remember, when we go along with the 2 pole, then speed of the machine will be rapidly increase. When we are reducing the pole, then speed will increase. But DC machines are always what, armature windings வந்து நம்ம ரோட்டார்ல ஃபிக்ஸ் பண்ணியிருக்கிறதால DC machine வந்து ரொம்ப ஹை ஸ்பீட்ல ரன் பண்ண விட முடியாது, because it will be subjected to very very high electrical stress. ஸோ என்ன பண்ண மாட்டாங்க அப்படின்னா, டிசி மிஷின் வந்து அவ்வளோ ஸ்பீட்லலாம் ரன் பண்ண முடியாது. ஸோ மோஸ்ட்லி வந்து என்ன கன்சிடர் பண்ண மாட்டாங்கன்னா, இந்த 2 போல்ஸ்லாம் கன்சிடர் பண்ண மாட்டாங்க. ஐ எம் ஜஸ்ட் டாக்கிங் அபவுட் தி ப்ராக்டிக்கல் சினாரியோ. ஸோ ப்ராக்டிக்கலி தி கன்க்ளூஷன் இஸ், வேவ் வைண்டிங்ல இன்டியூஸ்ட் ஆகிற வோல்டேஜ் வந்து ஆல்வேஸ் இட் இஸ் ஹையர் தென் தி வேல்யூ ஆஃப் லேப் வைண்டிங். தட் இஸ் தி ஃபைனலைஸ்டு கன்க்ளூஷன். Similarly, here itself I would like to conclude one more thing. See, in lap winding, we have more number of parallel path. It means what will happen when we are increasing the number of parallel path. See, suppose if parallel path is taking 10 ampere, then total parallel path will take, what will happen? Each and every parallel path will take 10 ampere, 10 ampere, 10 ampere, such that the overall parallel path will become 40 ampere. I can say the total current will become 40 ampere. If you again increase the number of poles into 8, then what will happen? It will be broken into 8 paths. So when you are reducing the number of turns, again what will happen? In the 400 வந்து நம்ம 8 divide பண்ணுவோம். அப்போ ஒவ்வொரு லைன்லயும் வந்து என்ன வரும் அப்படின்னா 50 turns தான் வரும். When you are reducing the number of turns, resistance of the coil also will decrease, such that the current carried by the coil will increase. So what is the conclusion here? The conclusion is, lap windingல அப்படி கிடையாது. Two lines are fixed. அது எவ்வளவு கரண்ட் கன்சியூம் பண்ணுதோ அவ்வளவு கரண்ட் தான். ஸ்டார்டிங்ல 10 ஆம்பியர் 10 ஆம்பியர் தான், அதை நம்ம சேஞ்ச் பண்ணவே முடியாது. So the conclusion is what? In wave winding, sorry, this is wave winding. In wave winding, current rating is very less. But in lap winding, current rating, we can carry more current. So what is the conclusion? Lap winding is subjected to low voltage, high current. Low voltage, high current. Right? If you go with the wave winding, what will happen? Now you can choose what will happen in the wave winding. So in wave winding, just now we saw it is subjected to high voltage, low current. high voltage, sorry, low current. So that is the beauty of these two. Okay sir. So what is the correct answer? நம்ம கொஸ்டின்ல என்ன கேட்டிருந்தாங்க அப்படின்னா எந்த வைண்டிங் வந்து இருக்கிறதுலே வந்து அதிகமான வோல்டேஜ் வந்து இன்டியூஸ் பண்ணும். That is the question. I had given the answer for that question. So the correct answer is wave winding. Here it is subjected for high voltage and low current. Lap winding means low voltage and high current. That's all. Now read the next question. Wave winding is employed in a DC machine of, you know the answer. Wave winding means high voltage, low current. High voltage, low current. Option B is the correct answer. Okay, I hope you all understand this logic. Chalo. Take the next question. In a progressive simplex lap winding for a 4-pole 40 slats 2 coil sides per slat in a DC armature, the back pitch YB and the front pitch YF respectively are dash. That is the next question. I know some of you might know the answer for this question because it is a direct formula. If you substitute the formula, you will get the answer. You can try it by yourself if you want. If you don't get the answer or if you don't have any idea, you can keep your attention here. Okay. So it is clearly told that what they told, it is lap winding, right? So first they told the winding is lap winding. First conclusion. So in a progressive lap winding, they told us something they data given, right? So in a progressive simplex lap winding, it means what? Progressive lap winding, the relation is back pitch equal to front pitch plus 2. That is the relation between back pitch and front pitch. First conclusion. Okay. This is very simple only. And next thing is, if you are calculating the average pitch, average means it is the addition of back pitch, front pitch divided by 2. That is called average. Yes, sir. Now, if you observe the question, how many number of poles are given in the question? The total number of poles given as 4, first data, and the total number of slats given as 14. And how will you calculate the total number of coil? I just wanted to know the total number of coil. Number of coil means total conductor they had given, right? 4 pole, 14 slats, 2 coil sides per slat. So what they told, number of coil sides per slat is 2 and the total slats are 4. They told 2 coil sides per slat. So totally how it will become 28. Okay. Now the next conclusion is this is total coil side. This total coil side is equal to back pitch plus front pitch. Do remember whatever I am doing here. Okay. Total number of turns or coil will be equal to, it is the addition of back pitch plus front pitch. Just நம்ம என்ன பண்றோம், back pitch இதோட டைம் நீங்க நோட்ஸ் ரிவைஸ் பண்ணீங்கன்னா you might get the answer, right? If you are not aware of these things, you can also search in Google. Just go through for 5 minutes, you'll get the idea. Okay. So the number of coils is also equal to addition of back pitch plus front pitch, right? See, directly you can solve these two equations to obtain the answer, because now here I am having one equation, here also we are having one more equation. So what we can do is, here I will calculate y back pitch equal to 28 minus front pitch. Let us substitute here, then what will happen? Front pitch plus 2 equal to 28 minus yf front pitch. If I will bring it to the left hand side, it will become twice of front pitch equal to 28 minus 2 will become 26. So I can say front pitch will become 13. Yes or no? Yes, sir. So front pitch will become 13. If I will substitute it here, then back pitch will become 15. Back pitch will become 15. So see, if you observe the options, nowhere we are having this kind of answer, right? Yes, nowhere we are having this kind of answer. Then what can we do? But what we have understand here, the first thing is the value of back pitch. If you observe from this conclusion, the value of back pitch is higher than the value of front pitch. That is the first conclusion. That is the only conclusion. கொடுத்திருக்க டேட்டா வச்சு நம்ம கால்குலேட் பண்ணா நமக்கு இதுதான் வருது. பட் ஆப்ஷன்ல அதோட கம்மியா கொடுத்திருக்காங்க. இந்த சென்ஸ் தே ஆர் டெஸ்டிங் அவர் நாலேஜ். தே ஆர் டெஸ்டிங் அவர் நாலேஜ். இப்போ நீங்க செக் பண்ணி பார்க்கணும். நம்ம கண்டிஷன் என்ன, பேக் பிட்ச் ஃப்ரண்ட் பிட்சோட அதிகமா இருக்கணும். இந்த கொஸ்டின்ல என்ன சொல்லிருக்காங்க, ஃபர்ஸ்ட் பேக் பிட்ச் நெக்ஸ்ட் ஃப்ரண்ட் பிட்சை பத்தி பேசியிருக்காங்க. ஸோ பேக் பிட்ச் ஃப்ரண்ட் பிட்சோட அதிகமா இருக்க ஆப்ஷன் எது பாருங்க. I think only option A. So what is the correct answer? Option A is the correct answer. That is how they will give clue if they don't give the answer for this question. Okay, fine sir. Take the next question. The purpose of providing dummy coils in the armature of a DC machine is to dash. Why we are providing dummy coils in the armature winding? Is there any one of you having a basic idea for this? What is the purpose of providing dummy coils? That is very simple actually. But you can try. I'm just looking for. I'm waiting. I'm waiting for your answer. Okay. I would like to conclude something here. See, we know we are having two types of winding. One is called wave winding. Another one is lap winding. But the problem along with the wave winding is, in wave winding the number of conductors are fixed. Mostly the number of conductors are fixed. That is coil, I can say. Because we have in wave winding number of parallel paths is only two. In such cases, what will happen is, suppose I am selecting a machine. Let us take I am selecting a DC machine. The selected DC machine is having more number of slots. Let us take here having one slot, 2, 3, 4, 5, 6, 7, 8. Let us take we are having 8 slots. Now what will happen is, here we know in DC the number of conductors are fixed. So now we have started accommodating the conductor into the slots. It is filled and then it is filled. We are just filling. இப்போ நீங்க என்ன பண்றீங்கன்னா இருக்க காயில் எடுத்து வேவ் வைண்டிங் வந்து டிசைன் பண்றீங்க. ஒரு ஸ்லாட்டா காயில் வந்து ஃபில் ஆகிட்டே போகுது. அப்படி போகும்போது என்ன ஆயிடுச்சு அப்படின்னா, வேவ் வைண்டிங்ல வந்து காயில் வந்து ஃபிக்ஸடு. ஏன்னா டூ பேரல் பாத்துக்கு தேவையான காயில்ஸ் மட்டும் தான் நம்மளால கொடுக்க முடியாது. நீங்க கொடுத்து முடிக்கும் போது என்ன ஆகும் அப்படின்னா, சம் ஆஃப் தி போர்ஷன் மே பி எம்டி. அதை ஃபில் பண்றதுக்கான காயில் இருக்காது. பிகாஸ் we are designing wave winding. Wave winding number of coils fixed. We can't do anything. Then what shall we do with this empty place? In that empty place, அப்ப என்ன ஆகும் அப்படின்னா, இப்ப இந்த மாதிரி மெஷின் வந்து இந்த ஹோல் பார்ட் வந்து ரொம்ப வெயிட்டா இருக்கும். பிகாஸ் காப்பர் காயில் வச்சு நீங்க ஃபில் பண்ணி வச்சிருக்கீங்க. இந்த பாயில் எம்டியா இருக்கு. இந்த மாதிரி இருக்க ஒரு மெஷின் எடுத்துட்டு போய் இப்ப நம்ம கிரவுண்ட்ல வச்சோம் அப்படின்னா என்ன ஆகும், ஒரு பக்கமா சாச்சிக்கும். So there is no mechanical balance. There is no mechanical balance. Then what we are going to do? In order to provide this mechanical balance, we are providing the dummy coils into this empty slats. One and only purpose. இங்க என்ன பண்ணுவோம் அப்படின்னா, டம்மியா வந்து காப்பர் காயில்ஸ் we will provide dummy coils and we will just fill in order to provide the mechanical balance into the DC machine. So what is the correct answer? To provide the mechanical balance, we are using this dummy coil. Fine. Take the next question. A 6-pole DC armature has complex lap connected 720 conductors, 3 turns per coil and 4 coil sides per slot. Determine the number of slots in the armature and state whether the equalizer can be employed or not. That is the next question now. First try. Spend some time by yourself to bring the answer for this question. Suppose if you are not getting the answer, then I will help you. Nothing is there, but you have to apply your brain. Okay, well, let me solve by myself. Anyway, you can pause the video and you can try to bring the answer. Okay, fine sir. According to the given data, the total number of turns. Let me take the total number of turns. How will you calculate the total number of turns? Total number of conductors divided by 2. Total number of conductors is how much? 720 divided by 2. How much you will get? 360 turns. First term. But what they told is, clearly they told that 3 turns per coil. Each and every coil is having 3 turns. It means what? If I'll go with the total number of coil, now usually number of coil and number of turns are equal only. But in this case, what they have done is they have breaked it. They have given the total number of turns, but they are telling that the total number of coil is each and every coil is having 3 turns. Then what is the total number of coils? In that case, you have to take the total number of turns and divide it by 3, because what they told, each coil is having 3 turns. Now we know total turns, and we have to identify the total number of coils. How much you will get? 120. Then how will you calculate the total number of coil sides? Because again, they have been differentiated this one also, the total number of coil sides. What they had given, they clearly told that I think 3 turns per coil, 4 coil sides per slats. How much they are considering? 4 coil sides per slat. Now first, usually what will happen is the coil sides will be what? 120 into, we will have 2 sides, right? For each and every coil, we will have 2 sides. If you multiply it by 2, you will get 240. Next, we have to calculate the number of slats now. Number of slats. Sir, this is very important. Coil sides அப்படின்னா number of coils மொத்தம் 120. ஒவ்வொரு காயிலுக்கும் 2 sides இருக்கும். அதாவது it will be like this. This is one side, this is one more side, 2 sides. So அப்ப total number of coil sides வந்து 240. அப்ப total number of slats வேணும் அப்படின்னா total number of coil sides divided by, you have to divide. அவங்க என்ன சொல்லிருக்காங்க? 4 coil sides per slat னு கொடுத்திருக்காங்க. So if you divide it by, if you divide this, you will get the number of slats. Okay, that's all. Now what we must do is, question la என்ன கேட்டிருந்தாங்க, first question is total number of slats. We figure out that the total number of slats are 60. அடுத்து என்ன கேட்டிருந்தாங்கன்னா, equalizer, whether state whether equalizer can be employed or not. That is the question. That is, they are talking about equalizer ring. Actually equalizer ring வந்து design பண்ணும்போது, so while designing the equalizer ring, ஜென்ரலா நம்ம என்ன பேசுவோம் அப்படின்னா, we must talk about equipotential. That is very important. We have to create the equipotential picture. Equipotential picture வந்து நம்ம create பண்ணோம் அப்படின்னா, that is we have to design. அது எப்படி நம்ம பண்ணுவோம் அப்படின்னா, that is 2 into number of coils. 1 minute. 2 into number of coils. You can just remember 2 into number of coils divided by total number of poles. Okay. So equipotential pitch வந்து create ஆகும்போது, if you divide this, we know total number of coils 120, already we have been calculated here. Number of poles வந்து 6. So if you divide this, we are getting 40. So இப்போ நம்ம equipotential pitch வந்து create ஆயிருக்கு அப்படின்னா, இது எப்படி நம்ம இன்டைரக்டா தெரிஞ்சுக்கலாம் அப்படின்னா, இந்த ஃபார்முலா வந்து நீங்க calculate பண்ணும்போது resultant value வந்து integerல வந்தது அப்படின்னா, yes, that is equipotential pitch only. Equalizer ringல வந்து என்ன பண்ண முடியும்? It can be employed. Equalizer ring வந்து இங்க employ பண்ண முடியும். That is possible. Correct answer. Suppose value வந்து integerல வரல அப்படின்னா, that is not possible. See, இதெல்லாம் உங்களுக்கு something நீங்க புதுசா கத்துக்கலாம். No problem. Just learn and how to solve. அவ்வளவுதான். எப்படி சால்வ் பண்ணிருக்கணும் அந்த ப்ரொசீஜரை மட்டும் அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க. You can also go through the Google if you want to enhance your knowledge in equalizer ring and how to do these things at all. Okay? Fine, sir. Take the next question. The question is, a 250 voltage DC generator is run at a rated speed with no excitation. Do you remember? Excitation is 0. And it's running at what? Running at, okay. The open circuit voltage is what? That is the question now. Sir, what is the answer? Anybody? First, what you have to think is, sir, machine la excitation கிடையாது. It means induced voltage will be 0. அப்ப external output la voltage எப்படி சார் வரும்? Generally, what will you do? We will have the DC machine. Let me draw the equivalent circuit for your understanding. Generator, they are talking about generator, right? So they are talking about generator. This is the generator and we will consider the armature resistance. Okay, sir. When this value will be 0, what is the open circuit voltage? That is also 0 only. Yes or no? No, sir. That is wrong. Why? Why it is wrong? Why? Because DC machine is a very small machine. DC machine is a small machine. Very small machine means what? You can draw. What is the open circuit characteristics, the difference between synchronous machine and DC machine? If you draw in synchronous machine, open circuit means we will start field current versus open circuit voltage. We will start from zero and we will go like this. But if you go if you go along with the DC machine, how will you draw the voltage? It will start from somewhere else and it will go like this. What is the difference between this one and this one, sir? Synchronous machine வந்து high voltage machine. Actually நம்ம என்ன பண்ணிருப்போம் அப்படின்னா we all might read this concept residual magnetism அப்படின்னு சொல்லிட்டு ஒரு கான்செப்ட் நம்ம படிச்சிருப்போம். So what is the meaning of this residual magnetism? என்ன ஆகும் அப்படின்னா நீங்க மெஷினை ஸ்டார்ட் பண்ணும்போதே என்ன ஆகும் அப்படின்னா டியூ டு தி ரெசிடியாலிட்டி ப்ராப்பர்ட்டியால என்ன ஆகும் அப்படின்னா மெஷின்ல வந்து இட் ஹாஸ் வெரி ஃபியூ வோல்டேஜ் ஆல்ரெடி வந்து அதுல இருக்கும் நீங்க ஸ்டார்ட் பண்ணும்போதே வெரி ஃபியூ வோல்டேஜ். பட் சின்க்ரோனஸ் மெஷின்ல ரேட்டிங் ஆஃப் தி மெஷின் வந்து ரொம்ப அதிகமா இருக்கும். இட் வில் ஜெனரேட் இன் thousands கிலோ வோல்ட். அப்படிங்கிறப்ப இந்த ஃபியூ வோல்டேஜ்லாம் நம்ம கன்சிடர் பண்ண முடியாது. ஏன்னா கிராஃப் வந்து எப்படி ஸ்டார்ட் ஆகுனா ஜீரோ, அதுக்கப்புறம் 1 கிலோ வோல்ட், 2 கிலோ வோல்ட், 3 கிலோ வோல்ட் அந்த மாதிரி இருக்கும் ஒய் ஆக்சிஸ் கிராஃப். அதுல போயிட்டு நீங்க 3 வோல்டேஜ் 4 வோல்டேஜ் எந்த இடத்துல வரைஞ்சு காமிப்பீங்க? பட் நம்ம டிசி மிஷினுக்கு வரையும்போது ஸ்கேல் எப்படி இருக்குன்னா 1 வோல்டேஜ், 2 வோல்டேஜ், 3 வோல்டேஜ், 4 வோல்டேஜ் லைக் தட் பிகாஸ் தி ரேட்டிங் இஸ் வெரி லெஸ் ஆர் இட் மைட் பி இன் 100 or 50 like that only. So in DC machine, the rating of the DC machine is very less and the residual magnetism is significant. That few voltage also significant here. So that few voltage will always be reflected in the output terminal. Okay. So due to residual mechanism in DC machine, the output voltage will not be zero. It will have some 2 to 3 voltage. That's all. But in synchronous machine, we will not consider this effect because the rating of the synchronous machine is very, very high. So this effect is insignificant. Okay, so what is the correct answer? Now you can drop your answer. The correct answer is option B. Okay, this question I brought you for homework. I'm just giving the basic idea. You please try because this is beautiful question. For 4-pole lap wound DC generator has developed power of P watts and voltage E volt. Two adjacent brushes of the machines are removed as they are worn out. Burn ஆயிட்டு அதை எடுத்து வெளியில போட்டாங்க. Two adjacent brushes. Adjacent is very important. பக்கத்துல இருக்க ரெண்டு brush remove பண்ணிட்டாங்க. If the machine is operated with the remaining brushes, the developed voltage and power that can be obtained from the machine are dash. That is the next question. Okay, I'm just giving the basic idea for this question. You can try. This is a beautiful question and easy question too. Let us see. Well, let me take 4 winding here. Let us take a point here. Then let me take one more point. Let us take one more point. One more point. 4 brushes they told, right? Let us connect them. Okay. That is internal armature winding. I'm just designing it. Okay, this is second brush. I'm just attaching it. Chalo, we'll fix it somewhere here. That location is not perfect. And here what will happen? Let me fix. Okay, somehow we have designed. Let us take here. I'm fixing one brush, and here I'm fixing one more brush, and here let me fix one brush, and here I'm going to fix one more brush. Okay, fine, sir. These are all the 4 brushes. Generally, what will happen is opposite brushes will have the same polarity, right? Generally, opposite brushes, like if it is positive, then this will also be positive. Okay, fine, sir. So let us see. Let me take these two and I will attach them together. Okay, fine, sir. Next, and I am going to take these two, this one, and I will attach them together. Now let me pass the armature current here, IA, from the external terminal. Okay, with the voltage, let us take EA. The IA is coming here. After reaching this junction, we will have 2 parallel paths like this. Now what will happen? Armature current will be divided by 2. That is the basic structure of armature winding. Then this IA by 2 will go here, it will come. After reaching this junction, once again there are two paths. So what will happen? Again it will be divided by 2. So it will be overall it will be 4. Again see that this I by 2 will come here. Once again it will also be divided by 2, such that once again it will become IA by 4. Here also it will become IA by 4. Now at this junction, if you apply KCL, incoming current, see IA by 4 is coming, IA by 4 is coming, so the outgoing current is IA by 2. Again here IA by 4 is coming, IA by 4 is coming, so the outgoing current is IA by 2. Leaving terminal is minus. So here also leaving terminal is minus. So this IA by 2 will come here, will come here, will come here. Similarly, this IA by 2 will come, will come, will come. Again, if you apply at this junction, total overall current IA. This is the basic structure of the machine. Now see there, this is armature winding. In this winding only voltage will be induced. Okay. So this induced voltage will be fixed in the coil. We cannot change that. But current flow will be changed. Initially it is IA by 4. Now what they told is two adjacent brushes will be removed. I am just giving the clue now. Let us remove these two brushes. When the ரெண்டு brush remove பண்ணிட்டா திரும்பவும் நான் எப்படி டயக்ராம் வரைஞ்சனோ அதே மாதிரி நீங்க வரைஞ்சி நீங்க வெளியில இருந்து I என்ற கரண்ட்டை பாஸ் பண்ணுங்க என்ன நடக்குதுன்னு பாருங்க. That's all. Then you will get the or what you do one thing. இதை remove பண்ணிட்டு you will start from internally. Internally see இங்க என்னன்னா the ability of this winding can carry only IA by 4. That is the conclusion. டிசைன் பண்ணிருக்கிறபடி என்னன்னா ஒரு வைண்டிங்கால IA by 4 தான் நம்ம வந்து கேரி பண்ண முடியும். அப்ப இந்த ரெண்டு பிரஷை ரிமூவ் பண்ணிட்டு இன்டர்னலா நீங்க ஸ்டார்ட் பண்ணுங்க. இன்டர்னலா வந்து இப்ப எந்தெந்த வைண்டிங்லாம் வந்து வெளியில இருக்க சர்க்யூட் கூட கனெக்ட் ஆயிருக்கு. அப்ப இன்டர்னல் வைண்டிங்ல நம்ம எவ்வளவு கரண்ட் கேரி பண்ண முடியும்? லெட் அஸ் டேக் IA by 4. அப்ப IA by 4 எடுத்துக்கிட்டு அங்க இருந்து நீங்க வெளியில கொண்டு வாங்க. எக்ஸ்டர்னலா அப்ப எவ்வளவு கரண்ட் வந்து வந்திருக்கும்? எக்ஸ்டர்னலா வெளியில இருந்து உள்ள எவ்வளவு கரண்ட் வரும்? when each and every winding carry only IA by 4 ampere. That is what your work. Just simply redraw the circuit and calculate the resultant current. Current calculate பண்ணதுக்கு அப்புறம் voltage will be remain same. Induced voltage in parallel circuit will be remain same. It doesn't matter whether you are removing the brushes or not. Okay, நீங்க remove பண்றதால parallel circuit reduce ஆகும். But you cannot see இங்க 1 turnல 1 voltage induced ஆகுது, 100 turnல 100 voltage induced ஆகுது அப்படின்னா நீங்க 8 parallel path கொண்டு வந்தாலோ இல்ல 4 parallel path கொண்டு வந்தாலோ அந்த 100 voltage வந்து fixed தான், because in parallel circuit voltage will be remain same. So the induced voltage will be remain same. You must keep your attention with the current only. Calculate பண்ணதுக்கு அப்புறம் just calculate the power by multiplying E and IA, resultant current. You will get the resultant power and voltage. That's all. Okay, fine sir. I hope you all have understand this logic behind of this question. So we have seen so many things in our